I'm going to demonstrate to you the P1 starter code, which is the context switching application posted on the GitHub. I've updated with some new code, so please put the latest updates from GitHub. I also have updated the lab manual. Please also put the latest updates from the lab manual. I have the context switching project open already. So first I'm going to build it. Then I'm going to write. This is the hardware version, so the RAM target. And I stop at main. If you don't see your program stop at main, then most likely this target setting and the debugger, this one probably was checked. Okay, so if it is checked, then you won't stop at main. So I'm going to just uncheck it. Then it will stop at main. So now I'm going to bring up the putty. So most likely, whenever you log on to the lab machine, some previous run will show up on the putty, but that's fine. So I'm going to just reset the terminal. Now I'm going to step through the code. So step over, step over. All right, so the first thing you will see is dereferencing null pointer to get the initial SP. So this is very unconventional. You can see we can dereference a null pointer by using the physical address because the physical address 0 contains the initial SP value. And then if I step over, if I dereference the address 4, I get the entry point of this program, which is the reset vector. So you can do this because we're playing with the physical memory, not the virtual memory. If it is virtual memory, say on Linux, right, you run a program, you dereference the null pointer, you will get a core dump. So now I would like you to pay attention to the registers. For now, we are at reset. So upon reset, I remember we said we are at privilege level thread mode and we're using MSP. So this is our default state. So now I'm going to read the control register, which is 0. 0 means I'm using MSP, but 0 means I'm at a privilege level. That's good. So now, because we're at privilege level, we're able to read the MSP. We're able to read the PSP. Here I'm using the CMSIS intrinsic functions to get the registers values. All right, so now let us switch to the unprivileged level. So you can see now we're at unprivileged level and the control register gets updated. So any register that gets updated gets highlighted, all right, and PC keeps updating, right? And you can see R0, hence the input parameter, because we want to set it to 1, and then that's R0 gets updated. And then next step is I'm going to print something. I say I'm at unprivileged level because I now I got control register is 1. I should be at unprivileged level, control register is 1. And then now I'm trying to access MSP. I can't. I got 0. I try to read at PSP. No, I can't. I got 0. But actually you can see they do have values. So this is the demonstration to show you the access level matters. And you only see this part of code when you have this macro enabled in your build. When you submit, you should not have this macro enabled. And I'm going to show you the C and C++ type again to remind you where you can set up the compilation macros. So now we're ready to initialize the testing framework. So if I step into it, you can see we're at the testing framework file, which is the ae.c file. So please don't change this file. And here, basically, this function takes in how many test processes you want to initialize, and for each process, what is the process's information. For example, what's the entry point, what's the initial privilege level, what's the stack size, things like that. And then there's this callback function, which you can specify before you initialize an RTOS. I'm going to go back to show you the callback function, but here is a callback function you basically pass in, and then this is the argument of the callback function. So if you want the AE init to call some customized function, some callback function, here it calls it, and then this is the basically the mechanism for you to tell the AE init to run that callback function. And then once the callback function is executed, we call this particular function, which is right here, the setproc_info. This setproc_info will call another function called setTestProcs. This setTestProcs actually is defined in each testing processes file. So if you come here, you can see the very first function is the setTestProcs. So it supplies information about testing processes like what's the PID, priority, stack size, and entry point. So that's basically the AE.C. And now if I just step out, you can see I'm now ready to initialize my operating system. And then if everything goes well, we never come back right here. Okay, we never come back here. We only goes here if we only come here if something goes wrong. And remember I mentioned about the callback function. You can see the callback function actually is called pre-RTX init. So basically if you want to do anything before RTX init, and for now it takes no parameter, but you can define. So this particular file, you can change this particular function. And this is the pre-RTX init. So anything you want to do before RTX init, put it here. That's the callback function. So now we're at RTX init. Remember, this is a system call. So now I want to show you what exactly the system call does. How does it trigger the SVC0? So if you look at this one, okay, if you look at this RTX init, let me just step into it. We immediately get into the SVC handler. It is because this is SVC call, and the first thing we do is to disable interrupt. Remember, we said atomic on is to disable interrupt. So here in the assembly code, we disable interrupt, and then we read the MSP to R0. And if you look at here, now we're in handler mode and we're privileged and we're using MSP. Good. So all this block of code basically just tries to extract the SVC number. If it is 0, then we continue. Otherwise, we exit. So I'm just going to quickly step over. And then this is a multiple load. So we're going to load R0 with whatever is on the exception stack frame. So we load it, good, and then we push. We basically save R4 to R11, and then importantly, now we're ready to go to the kernel function. So if I just step into it, and you see we're inside the K version of the RTX init, which is the kernel function implementation of the RTX init function. So this is to initialize our RTOS, and the first thing we do is to do some memory initialization. Here we do very simple memory initialization, but what you want to do is to expand this thing. So if you go here, and you can see this is our memory initialization, and this is the memory map after the memory initialization. Basically, we need to allocate some memory for PCBs, some PCB pointers, and process stack. So this starter code gives you 2 processes already. So we do some memory initialization of all these data structure here. and then, so let me just quickly let me just get out from this routine, and you can go through the code to see what exactly it is doing. And then after I'm done on the memory initialization, you can see the kernel gets kicked off. I have 2 processes, process 1 and process 2. One prints uppercase letters, and the other one prints numbers. So what exactly are these processes? So if you come here, you can see these are the processes. I can set up a breakpoint right here. and it will stop here once it prints some numbers. Once process 2, and then I can set up another one here. So if I continue, this process starts to run, and then once it is done, it calls release processor. Release processor basically just frees up the CPU and put the current calling process to the back of its ready queue. And then we stop at process 2. So release processor switches the scheduling. And then if I just continue, and then you can see this process 2 keeps running until it calls release processor right here. And then we stop right here. So that's basically if I just kill out. So if you just let it go, you can see there's just the two processes alternating. So I want to bring up one point, which is the release processor. Release processor basically means whoever calls this function needs to be put back to its own ready queue. And then the scheduler will make the new scheduling decision. Okay, so in this starter code, we don't really have priority notion. We only have two processes, and you can think they have the same priority. So if I call release processor, then the other guy should run. And the other guy calls release processor, and then the previous one should run. So that's basically the starter code. So you can see it's already doing the context switching for you. And I'm going to just put a stop here. So now let it stop. So what do you need to do for part 1A? You need to implement the memory allocator, which we have the template code here. So now I want to show you one thing. If I go to the ae_proc.c file, which is where we have the testing processes, I can put a breakpoint right here. So now if I go into the debugger and then let the code run again, it will stop at request memory block. Alright, so now if I just and show you the assembly code, okay, you can see here we load R12 with the entry point of the K request memory block non-blocking version, and then that's the SVC0. So now I step into it, I'm inside SVC handler, and if I just go to this line and then step into it, you can see I'm at the K requested memory block, MB, non-blocking. And then if I step over, you should see the debug message, say K requested memory block, MB entering. It's not implemented, so you need to implement it yourself, because you basically need to implement these three functions in part A. So that's basically about the demonstration of the starter code. I'm now going to switch to the simulator target and let it run. I want to show you one thing about simulator. So if I'm running this thing and on the simulator, so I'm going to open up UART1 and UART number 2. No, I should open UART number 2. Okay. So this is my UART number 2. And if I step over, I want to show you one thing is these are all the same. So reading an MSP, that's fine. I got MSP. But if I want to read the PSP, you can see PSP is 0 inside the simulator. So by default, the simulator will basically initialize PSP to 0. But on the hardware, like if you really run the code on using the RAM target, it doesn't really have this initialization thing down. So I want to bring this point out because this shows the difference between the simulator and the actual hardware. There are many things like related to some real hardware addresses. The value at certain addresses will get initialized to 0 by the simulator, but not on the actual hardware. So you have to be careful about initializing certain memory regions value. So that's basically about the simulator part. So now let's talk about the file organization. In order to be able to use the automated testing framework, you need to keep the file organization as it is. So you can see we have a document where you have the README. So please do read the README. It talks about all the AE folders. So any source group that starts with AE, that's related to the automated testing. And then the system code, basically you don't need to change them. The only thing you probably need to change is the pre-RTX init if you need to do anything before RTX initialization. Leave everything else unchanged. You don't need to change these two files. For the kernel part, feel free to change them, and then you're supposed to implement them, actually change whatever you like. However, what you cannot change are these things. Let me just look at ae.h file. So pretty much any header files that we give you cannot be changed. So ae.h, I mean user level header file, you cannot change it. rtx.h file, do not change it. There's a common.h file, do not change it. However, any header file user level with _ext can be updated. So for example, common _ext.h file, feel free to add more to this file. And for the rtx _ext.h file, it's basically you can add like new functions to it. And here we added one more, which is the user level request memory block, non-blocking version of API. So here I added, but feel free to add more functions if you want to create more system calls for your kernel. So that's about the system code and header files. And for the kernel part, like I said, feel free to modify them, but don't change the existing function prototypes. And for the AE folder, I have ae.c and ae_util.c, which are the utility functions that we use to write automated testing framework. For now, I don't use the framework's utility, but I'm going to release some code that makes use of the functions in the utility so that you can see we can make this testing more automated. So here, this I have like ae.h, ae_inc.h, ae_util.h. So please don't modify these files, but you can certainly modify the implementation of the functions that are declared in these files. For the AE active, that contains the testing suite itself. So for now, I just put a dummy one here, and it is called AE proc.c, which we're already saying, right? So two processes, they alternate. And there's the ae_proc.h file, which please don't change. So header file, pretty much, any user level header file, don't change it, except for those one with the name, where the name has _ext in the naming. Okay, so this is basically the testing suite. Now you will find two folders right here. They are kind of, they have this stop sign there. Why is that? It is because they are not included in the build by default. So how do you exclude a folder from the build? You do right-click, options for group, and then if you want to include it, you just do this. This is by default included. If you want to exclude it, then you just uncheck it. So that basically means at any moment when I build this project, all the files under these two source groups, they won't be built. Into my image. So this is the mechanism I use to have different test suites, because we need to write multiple testing suites. And for each testing suite, it is a C file. And I cannot have two testing suites coexisting at the same time, because otherwise I will have multiple symbol definition problem. I will show you what I mean. So for example, this is a testing suite. If I put it here, then if I build it, then we'll get errors. Because they all have the same symbol, the testing process symbol defined. So at any moment, I can only have one file here, and I drag whatever I don't use to the corresponding folder. So this is a testing suite, so if I build it, then now it should work. Okay, and by default, I will just put this one here. And when you submit your project, you should leave this one here. You should make sure with this one here, the project builds. And then this part is written by us, and this part is written by you. I put 3 template files, like testing template files, for you to write your own testing suites. And usually people will find, writing a testing case probably requires one single testing suite file. So one testing case, one testing suite, but sometimes you can also have multiple testing cases in one testing suite. But either case, our requirement is for you to submit 3 non-trivial testing cases. So you can either submit one single testing suite file with 3 non-trivial testing cases, or you can submit a multiple testing suite file where each testing suite file may have 1 or 2 testing cases, up to you. So these are the file structures. If you go to the file system, under the source, here are all the files. So you can see these source groups are just the logic views. So feel free to add more files to this source group, source folder, no problem. Yeah, I guess that's basically about the testing framework, or what you can change and what you cannot change. Now I want to show you the target option setting. Under the C and the C++ tab, we have defined a whole bunch of macros. Well, this SE350 demo and debug demo, these 2 macros, they are for demonstrating starter code purpose. When you submit your code, you should remove these 2 macros. And for this AE_enable, if we want to use the automated testing framework utility functions, then we can put this macro in. For now, the starter code, this one and this one, they don't really use the utility function, so it doesn't really matter whether you put this macro in or not. The other thing is the target option setting is per target. So when you submit, you should make sure both targets have these 2 macros removed.